In this video, we are going to learn a technique for unit conversions called dimensional analysis. Dimensional analysis is a mathematical computation tool based upon the premise that the units of quantities must be subjected to the same mathematical operations as their associated numbers. Or more simply and easier to remember, follow the units. So in order to learn dimensional analysis, we're just going to dive right in and start doing examples. So our first example is here. The problem is I'm ordering an IKEA item. I've measured my space in inches, and IKEA states the size of the item in meters. Now, without just using Google, because we're learning dimensional analysis, how do I compare these two things? I know that 1 inch equals 2.54 centimeters. So the first thing that I'm going to do with dimensional analysis is sort. I'm going to figure out what I have and what I need. Have been given 30.2 inches. And I want to find that value in meters. And I have a number of conversion factors. One of them is given to me right here. 1 inch is equal to 2.54 centimeters. However, I'm going to need another conversion factor because I want to go to meters, and a table with these conversion factors of our unit prefixes. I know that centa is 10 to the minus 2. So we can write that conversion factor down as well. That 1 centimeter is equal to 10 to the minus 2 meters. Great. So then I'm going to plan what I'm going to do. I'm going to say, start with inches. We'll convert to centimeters using this first conversion factor that I have, and then we'll convert to meters using that second conversion factor. And we're going to do it all in one step. That's the beauty of dimensional analysis. We don't have to pick up and put down our calculator multiple times. So we now are going to set up the problem. We say we start with 30.2 inches. Here's the most important part of dimensional analysis. Always write your units. I will take off a lot of points if I see that you don't write units. So 30.2 inches, and then we're going to multiply by our conversion factor. Inches is in the numerator, therefore it needs to be in the denominator here to cancel out. So we'll put centimeters on top. We're going to say 1 inch is equal to 2.54 centimeters. That's our first conversion factor. Now we've gotten rid of inches and we're in centimeters, so we're going to do the same thing. We're going to get rid of centimeters and we'll turn it into meters. So we need centimeters on the bottom, and we can put meters on the top, and then we just put our conversion factor in. 1 centimeter is equal to 10 to the minus 2 meters. Now our centimeters cancel, and we end up with meters. So our check before we plug and chug this in our calculator, get rid of inches, get rid of centimeters, we end with meters. So now we can pull out our calculators and double check, and we should end up with 0.76708 meters. Are we done? No, not quite, because we still have to think about sig figs. We had 3 sig figs here. So that means we'll have 3 sig figs. We can just put a underline under our sig figs, and we can rewrite our answer as 0.767 meters, or we can use scientific notation, 7.67 times 10 to the minus 1 meters. There's our answer. Great. We want to, at the very end, just check. We make sure our units cancel. We do a concept check. So first our units cancel, inches, inches, centimeters, centimeters. Yes, we get meters. Great. Concept check here, we can say, oh, well, meters is a much larger measure of unit than inches. Therefore, our answer should be a smaller value than what we start with. We start with 30.2. We end with 7.67 times 10 to the minus 1. Yep, our concept check makes sense. Great. We sorted. Then we figured out our plan. Then we solved. We set it up and solved. And then we did a double check. And the whole time we followed our unit. So now that you have seen how dimensional analysis works, go ahead and pause the video, work through these set of practice problems, and when you're done, restart the video because we will work through all of them together. Okay, welcome back. Let's start with practice problem 1. Hopefully this problem looked really familiar. We are given 3.02 inches. We want to find meters. And we have conversion factors here. 1 inch is equal to 2.54 centimeters, and 1 centimeter is equal to 10 to the minus 2 meters. So our plan is going to be inches, 2 centimeters, 2 meters. We start with 3.02 inches. Make sure we put our units in. I'm just going to write this a little bit differently than I did before. So you can see it doesn't really matter if you put it in parentheses or put it in multiplication sign. However you do it, it's still the same. So now we're going to put inches on the bottom and we want centimeters on the top. We put our conversion factor in, 1 to 2.54. Our next step is to get rid of centimeters and turn it into meters. And so 1 centimeter is equal to 10 to the minus 2 meters. Now we're ready to plug and chug this. And we should end up with 7.67 times 10 to the minus 2 meters. We do our check. We say our units cancel. We end up in meters. That is correct. This value should be smaller than this value because meters is a larger unit, and that is correct. Nice. Okay, next step, or next problem, how many seconds are in 1 year? And you've got a really big hint right here. Convert years to days, to hours, to minutes, to seconds. And the conversion factors hopefully are in your head. Okay, so we've been given, let's switch color, sorry, we want to use blue. We've been given 1 year, and we want to find seconds. Our plan is to start with a year. We will convert to days. We know that 1 year is 365 days. Then we'll convert from days to hours. We know that in 1 day, that in 1 day there's 24 hours. And then from hours we'll go to minutes. We know that there's 1 hour and 60 minutes in 1 hour. And then we go to seconds. We also know that there are 60 seconds in 1 hour. So then we'll set this up. We'll start with 1 year. Again, really important to write in the units. We want years on the bottom and days on the top. So we have 1 year is 365 days. Make sure you don't flip those values. Often somebody with the most common types of errors I'd see would be 1 over 365, and people would do something like this. That is wrong. So be very careful. Okay, we're going to delete that so we don't confuse anybody else. And oops. There we go. Okay, let's get back to this. So then we want to convert from days to hours. So days are on the bottom, hours are on the top. 1 day is 24 hours. Now we want to convert from hours to minutes. 1 hour is 60 minutes. Now we want to convert from minutes to seconds. 1 minute is 60 seconds. Great. So let's double check before we plug and chug. Years, we get rid of years. We get rid of days. We get rid of hours. We get rid of minutes. We end up with seconds. So now we're ready to put this into our calculator. And, oops, how about the equal sign there? And get rid of that. Okay, and you put this in your calculator, we should end up with 3.15 times 10 to the 7 seconds. Nice. We do our concept check. Year is a much larger unit of measure than seconds, so this value should be much larger than this value. That is correct. Let's go back and just make sure. 1 year, 365 days. 1 day, 24 hours. 1 hour, 60 minutes. 1 minute, 60 seconds. We canceled all of our units. Our concept check and our math check look good. Let's move on. This problem is significantly more challenging. Remember that 1 liters are the common unit of measure for volume, but meters cubed, which is shown over here, is the SI unit. SI and common. And I gave you this conversion factor in a previous video. And so we've been, in this problem, we know that we've been given 1 liter. That's our common. And we want to find centimeters cubed. Okay? And our conversion factors here, well, this is the first one. We can go liters to meters cubed, and then we need to go meters cubed to centimeters cubed. And we know here that 1 centimeter is equal to 10 to the minus 2 meters. So we can use that conversion factor. The challenge here is that this is just meters to the 1 and this is centimeters to the 1. And we need to go to between centimeters cubed and meters cubed. Okay? So we're going to address how to do that when we get to that point. So our plan is to go from liters to meters cubed, and then from meters cubed to centimeters cubed. So now let's set this up. We'll start with 1 liter. Goes, well, how about, let's start that over. Okay, so now let's do the setup here. We start with 1 liter. We're going to multiply that by our conversion factor. We get liters on the bottom. We want meters cubed out. So 1 liter is equal to 0.001 meters cubed. Our next step is to convert between meters cubed and centimeters cubed. But we don't have that conversion factor. What we do have is that 1 centimeter is equal to 10 to the minus 2 meters. Okay? And here is a big hint. When you cube the units, you have to cube the values. So we know we want centimeters cubed and meters cubed, so let's just cube this whole thing. Okay? And then this is then going to be equal to 1 cubed centimeter cubed over 10 to the minus 2 to the 3 meters cubed. And if you remember back to high school math, the rules of exponents, a to the n all to the n is equal to a to the n times n. So that means this is equal to 1 cubed is 1, so we're just going to write that. 1 centimeter cubed over 10 to the minus 6 meters cubed. Great. So now we plug this in up here. I'll change to blue. 1 centimeter cubed is 10 to the minus 6 meters cubed. Great. Now we can double check. Liters cancel, meters cubed cancel. We get centimeters cubed out. And when we plug and chug that, we should end up with 1,000 centimeters cubed. All right, I'm just going to move this over here, give myself a little bit of space, because question 4 is related. Okay, question 4 now says, based upon your answer, here's our answer, 1 liter is equal to 1,000 centimeters cubed. How many milliliters are in 1 centimeter cubed? Well, we'll start with this answer. 1 liter is equal to 1,000 centimeters cubed. And the question is, what's the relationship between centimeters cubed and milliliters? So we know the relationship between liters and centimeters cubed, so let's look at the relationship between liters and milliliters. Okay. Well, up here we say 1 milliliter is equal to 10 to the minus 3 liters. That's thousandths place. So that means 1 milliliter is equal to 1, 2, 3 liters. So if we want to convert 1 liter to milliliters, we just go 3 decimal places over in the opposite direction. Remember that that shortcut I gave you. So 1, 2, 3. That means it's 1, 1, 2, 3 milliliters. Okay? So 1 liter equals 1,000 milliliters. Wait, 1 liter also equals 1,000 centimeters. That means 1 centimeter is equal to 1 milliliter. So 1 to 1. The reason I harp on this is because, centimeters cubed. How about that? Centimeters cubed is also called cc's. In hospitals, it's often called cc's. And I was once getting my blood drawn by a phlebotomist who had some units of milliliters and then something else, the units of cc's. And that person had a heck of a time trying to figure out what was what. And I realized that if I ever taught general chemistry, I needed to make sure that any of my students that might end up in the hospital knows that cc's is the same thing as milliliters. So don't get caught by a chemistry professor coming in as one of your patients and schooling you on that. Yeah? Okay. Oops. So we're at the end of the dimensional analysis. In our in-class session this week, we will work on our dimensional analysis worksheet. That's why I was being funky. Seriously, computer, you are being challenging today.